right, if you can divert your attention up here for, again, just a few more minutes, and then I'll let you have the remaining time in class to continue working on this assignment. Okay, but the last little bit of material in here is split. Some you know and some is new to most of you. Okay, first, just number representations. As far as the number line goes, everybody is familiar. As you move to the right on a number line, numbers increase. As you move to the left on a number line, the numbers decrease. And the reason I bring this up is we're going to be talking about some interval sets or sets of numbers that fall into relationships between specific numbers. And the form that you guys are the most familiar with is the inequality form. And so if we look at the inequality notation for a relationship of numbers on a number line, x is less than -2 just means that you're looking at all the values that fall to the left of less than, it decreases to the left of -2. And there's two other forms that you need to be aware of, and you need to be able to move between all three of these. The first of those is the graphical notation, and then the last one, and those two are ones that you've probably already seen. The next one you probably haven't been exposed to yet, and it's called interval notation. Okay, the graphical notation would represent, again, your number line. You'd plot your critical point or points. Here we only have one critical point, the real number -2. And then we want to include the entire set of numbers that are less than -2. So less than means we move to the left. Okay, so we're going to highlight the set of numbers that are to the left of -2. Okay, and is -2 included in this set? No, it doesn't have an equal to. Okay? And so when you're looking at this, you guys are used to looking at the graphical model with what to indicate not included or excluded. An open circles. Okay, so what you guys remember or learned in algebra as an open circle, this means excluded. It's not going to be part of the solution. We're going to replace the open circle with parentheses. Okay, not necessarily both directions, okay, but this is for less thans or greater than or less thans symbols. If they don't have the equal to in it, okay, meaning that you'd have that open circle of exclusion, we're going to replace it with a parentheses, and we're going to open that parentheses in the direction of the graph. Okay, so here's our solution set. We have a parentheses at -2 opening to the left because it's all the values that are less than -2. And this extends all the way to infinity in that direction. Okay, you don't need to write this down. I'm just writing it because I'm going to refer to it in the next notation form. Okay, so this right here is all you would need to represent the graphical notation of this inequality. Okay, the final notation form is one that is probably new to everybody, and that's interval notation. And with interval notation, you're going to take a look at the critical points. You'll start with the furthest to the left. So in this interval here, what number is furthest to the left? Is there a specific number for that? No. If there's no number here, you do need to designate that it's infinity in the negative direction. And then what's the number that's furthest to the right? -2. Is -2 included in the set? No, so it's a parentheses there. And can you ever actually reach infinity? No. So what do you think it'll be? Parentheses as well. Okay, now, if you're dealing with something that would be the closed circle, okay, representing inclusion, instead of a closed circle, we're going to use brackets, and this is for greater than or equal to or less than or equal to. Anytime you have the equals, you'll use a bracket. Okay, so let's take a look at an example that involves that. Okay, if we said x is greater than or equal to 3/2. Okay. Here's our inequality notation. If we wanted to find the corresponding graphical notation, we plot the critical point, 3/2. We identify the solution set. It's all numbers x that are greater than or equal to this number. Greater than means we're increasing or moving to the right. So we'll highlight the set of numbers that are to the right of 3/2. It does have an equal to in it, so we're going to use the inclusion grouping symbol. And the easiest thing to remember this by is if you just draw in your equal sign at that critical point and then connect it with a vertical line, you actually have your brackets. Okay, so here would be the graphical notation for this interval. And again, you don't need to write this, but it extends all the way to infinity. So now when you write your interval notation, you start with the lower limit. The furthest point to the left is 3/2. Our upper limit, or furthest point to the right, is infinity. Infinity can never be reached, so it's always a parentheses there. Our 3/2, is that included in the solution set? Yes, inclusion represents the bracket. And now, anytime you're dealing with infinity in your interval notation, these are referred to as unbounded intervals. It doesn't matter whether they have brackets or parentheses. If there's an infinity in it, then it's unbounded. Basically, in the graphical form, if it extends without limit to one direction or both, then you're looking at an unbounded interval. Okay, let's say we take a look at this inequality. So now we have a value of x that's located in between two limits, a lower limit of -3 and an upper limit of 10. Okay, our graphical notation now will have multiple critical points. You're going to plot all your critical points, so -3 and 10. Okay, and then you look at each one independently. So if we look at this first set, this first interval, x is greater than or equal to -3. So that represents the set that's to the right of -3. So you're highlighting everything to the right of -3. You would then look at the second interval set. X is also less than 10. So x is less than 10 is indicated by the value 10. Less than means to the left of. So everything to the left of 10 would be in your interval set. So all the overlapping pieces would be your solution. Okay. Then you can go in and find the correct grouping symbol based on inclusion or exclusion to the set. -3 is less than or equal to, so will we have a bracket or parentheses? A bracket indicates inclusion. The 10 is, or x is less than 10, so will that be bracket or parentheses? Parentheses. So here is our graphical notation. And then this can be translated directly into our interval notation. Our lower limit of -3, upper limit of 10, a bracket at -3, a parentheses at 10. And here, because there's no infinity in it, we're looking at a bounded interval.